Hello class and welcome to our final video.
Oh, how the time flies in the statistical world of numbers and fun. Okay, anyway.
Sorry class, sorry.
Today we are going to be discussing inference for distribution of categorical data,
which is a complicated way of saying we are going to be analyzing, carrying out, and learning about a chi-square goodness of fit test and all the components involved.
We begin by stating our hypothesis. It should state a claim about the distribution of the single variable in the categorical data and say that it is correct. The alternative hypothesis is that the distribution is not correct.
The point of a chi-square test is to compare the observed counts with the expected counts in the categories of data you are looking at. The formula is sigma observed minus expected squared over expected.
The chi-square distribution only takes the positive values and it is skewed to the right. The test also uses degrees of freedom of the amount of categories minus 2. For example, if there were 6 different colors we were testing, the degrees of freedom would be 4.
But first, you must check conditions. The first is random. The second is having a large sample size. All expected counts must be at least 5, and the last check is independence. If you are sampling without replacement, you use the 10% rule.
Once you have found the degrees of freedom, you have found one of the key components of this test.
You're not quite there, though. Use Table C in the degrees of freedom to find either the p-value or the chi-square statistic.
So when you use the previously mentioned equation of sigma observed minus expected squared over expected, you get the chi-square statistic, so you'll be able to find the p-value based on the degrees of freedom.
If you're like me and prefer to use your calculator to find these things out, there's a nifty stat test that you can use.
Grab your calculators, kids! So, grab your calculators and hit Stat Edit and enter all of your data into your lists. In your first list, you'll have all the observed numbers. In your second list, you'll have all the expected numbers. In the third list, you'll have observed minus expected. In the fourth list, you'll have observed minus expected squared. And in the last list, the most important, is observed minus expected squared over expected. So, let's use this example of M&Ms. So, we have the observed M&Ms in our bag, and then we have the expected number of M&Ms. So, Mars Candy puts out that there should be 24% blue candies, and so you find the amount of candies in each that are expected, and then you subtract from your observed number, and then you do observed minus expected squared so that you have all positive numbers. And then in the last row, you will have the observed minus expected squared over expected, which is our numbers for our chi-square goodness sum. So then, once you have all of your data entered into your calculator, you hit Stat, and then you go to Tests, and then you go to the goodness of fit test, and then you hit enter, and you put in the observed list, which is list 1, and the expected list, which is list 2, and the degrees of freedom, which is 4, because we have 6 colors, so we have 4 degrees of freedom, and then you hit calculate. This will give you your chi-squared variable, which is 10.18, and then your p-value, which is 0.0375.
Because p-value is less than the significance level of 0.05, we can reject the null hypothesis because the chance that the chi-square statistic or something more extreme would happen by chance is very small.
Thank you, class.
It's been really fun.
We hope you enjoyed our last video.